So the really big idea in 2.7 is solving equations that have rational portions of them, meaning fractions. Did you guys talk a lot about fraction busting last year in Algebra 2? So that's basically what this is. It's just all fraction busting. There's not a whole lot in the way of notes. Really, we're just going to go through a few examples together. So as we go through these, please ask questions, and I can kind of expand further if there's something that you don't understand. But 3 examples today, and we'll call it good. So example the first is the equation 2x plus 11 all over 7 plus quantity x plus 9 all over 7 equals 5 over, you guessed it, does this look kind of familiar? Last year, you would have done some problems that looked, I'll just kind of give you a preview of what's to come. That's our first equation. You guys remember doing problems that had like x's and then denominators also? Does this look familiar from last year? So we're going to go through, those are the 3 examples we'll do. We'll go one at a time though. So the whole idea with these is fraction busting. Has anybody never heard that term fraction busting before? You guys have all heard it. It means you multiply through by the denominator. So fraction busting means you multiply it through by whatever's in the denominator, and that gets us an equation with no more fractions. So the whole idea is if I have, say, something with 7 in the denominator, if I multiply this fraction times 7, that 7 multiplication and that 7 in the denominator cancel each other out. And it just becomes 2x plus 11. All right, but the rule of algebra is if we're going to multiply one thing in the equation by 7, we have to multiply everything in the equation by 7. Okay, so to do this, I would need to multiply each of these terms, each of these rational terms by 7. That's going to end up canceling out all those 7s, and I'm just going to be left with the equation 2x plus 11 plus x plus 9 is equal to 5. And I'll let you go ahead and finish solving that on your own. We're coming up with -5. Sweet. So this was pretty basic first example here. I'm going to call us about halfway done with this. The book is going to ask you for each of your homework problems to verify either algebraically or graphically. Oh no, they'll say verify numerically or graphically. So how would you verify a solution numerically? What do I tell my Algebra 1 students to do every time they solve an equation on a test? What do you think? Theo? Back in, yeah. So if I ask you to verify this numerically, I would want to see the work that says 2 times -5 plus 11 over 7 plus -5 plus 9 over 7 equals 5 over 7. And do a little bit of work on that and make sure that it ends up coming out to be true. That's -10 plus 11. That's 1 over 7 plus -9. -5 plus 9 is 4 over 7 equals 5 over 7. That's good enough for me. That's true, isn't it? One seventh plus 4 sevenths is 5 sevenths. Check. So our solution is x equals -5. We have verified numerically. And when we did that, we just took our original equation and took that -5 and popped it back in here for x. Back in algebra 1, we would have said check your answer using substitution. Let me show you another way that you can verify. It's a little bit, could be a little bit quicker. If I wanted to make this equation into something that equals 0, would you be able to do that? Could you rewrite that equation to something that equals 0 pretty quickly? Sure you could. You would just subtract this from both sides, right? It would say 2x plus 11 over 7 still. Plus, we still got x plus 9. It would be minus 5 over 7, and then it would be equal to 0. I just took that 5 over 7 and scooched it over to the other side. It became a -5 over 7. Agreed? You okay with that? All right, get up your graphing calculators. And we're going to verify numerically using the calculator. So this is going to go into y1. Careful with your parentheses when you're doing these. And we're just putting the part on the left-hand side. We're not putting the equal to 0 in here. When you got that all in there, go ahead and have a look at what it looks like. And the shape of this graph is not super important to us. And I guess it's going to be a line. Because there's no x's in the denominator, so we shouldn't have any vertical asymptotes. All right, and does anybody need a minute? The universal sign here. We good? Okay, from here we're going to use second calc value. So I'm going to do second trace. That's my calculate menu. I'm going to go value. What value do you suppose we're going to plug in for x? -5. That was our solution, right? So I'll put -5 in for x. And what am I hoping that x or that y ends up being when I put -5 in for x here? We hope that y comes out to equal 0. So we're checking to see if this whole thing ends up equaling 0. So I put -5 in there, and boom, it spits out 0. That makes me feel good. There is a third way to do this, also using the calculator. I want to show you this as well. Don't think we've used this in this class yet. We could take this thing and find the zeros of it. So this is also in the second calculate menu. So go to your calculate menu and choose option 2, which is 0. It's going to ask you for a left bound, a right bound, and a guess. So left bound, I move it a little bit left of the x-intercept. Right bound, I move it a little bit right of the x-intercept. Guess, I move it right on top of the x-intercept. Hit enter, it'll think for a second, and I'll spit out what that x-intercept is. And again, since I'm getting -5, All right, so there's example number 1. Any questions on example number 1? Questions. All right, here we go. Number 2. So this one's going to have some x's in our denominators. So that's the equation. Usually when I'm working with these equations, when I copy them down out of the book, I will copy them down with lots of space in between the pieces. So I'm going to rewrite this and put some space in between. So doing this problem is going to involve us finding the least common denominator for the original equation. So when I'm finding a least common denominator, I want to look at the factors that I see in the original equation and make sure that those all appear in my lowest common denominator. So when I look at this, I see a factor of x. So my lowest common denominator is going to need a factor of x. And I see another factor of x plus 2. So my lowest common denominator is going to need an x plus 2 in it. This has a factor of 1 in the bottom. That's already kind of included by default there. So my LCD should be x and x plus 2. You're going to know if you got your LCD right if everything cancels out in your first step here. So your first step is to multiply each of your fractions by your LCD. And we're fraction busting here, so we should end up deleting or canceling all of our denominators. Is that going to happen? Like here, I got an x and an x that are going to cancel, so those are gone. This x plus 2 that's dividing matches up with this x plus 2 that's multiplying, so those are gone. Nothing's canceling in this last piece here, so everything's going to stay there. So after all said and done here, I should have a fraction with no more denominators. And that's good. Because we can solve those. So do a little simplifying there, see what you come up with. Yes, question.
Why couldn't you just multiply it by x?
Just by x and then by 2? That's a really good question. Thank you for asking. So here's a really common misconception when people are looking at this. If I had, I'm going to change the problem up a little bit. If I have x over x plus 5, can we cancel these x's? No, we can't. We cannot. X is a factor of the top. The factors of the top would be 1 and x, agreed? But x is not necessarily a factor of the bottom. This is its own factor altogether. Now, if I change this and it was x over 5x, now can I cancel the x's? Now I can, yes, because the x is a factor in the top and bottom. So if I had multiplied everything by x, it wouldn't have canceled just this x. We would have had That wouldn't have canceled the x. You see the answer to the question now. So I'm really glad you asked that question because super common misconception. People will look at this and they'll say, well, it's got an x and it's got an x plus 2. I should be able to just multiply by x plus 2. That should take care of both of them, right? Very, very common. But that doesn't work because x is not a factor of this denominator. So multiplying this by x isn't going to cancel that x. And if I were to multiply this by x plus 2, I couldn't just cancel the x's because they're not matching factors. Great question. Thank you for that. Other questions before we move on? All right, let me catch up to you guys. Did you end up with 3x plus 6 plus x equals 5x squared plus 10x? And you probably did some combining like terms and turned this into 4x plus 6 equals 5x squared plus 10x, maybe? That looking good so far? Yeah, that's a quadratic, right? Quadratics. How do we solve quadratics? Yeah, we got a couple options. What are our options? Yeah, give me one. Quadratic formula, in which case we need a 0 on one side. Or what's the other option? Factoring, in which case we also need a 0 on one side. So let's go ahead and get a 0 on one side. Since my x squared term's over there, I want to leave that positive. So I'll get a 0 over here. So minus 4x on both sides would get me what? 6x. Minus 6 on both sides would give me minus 6. Man, I would love it if this thing factored. I got a strong feeling that it doesn't, though. It doesn't? Have you tried? Oh, I really wanted to. I'm going to try real quick. 5x and x is the only way to get 5x. So this is either 1 and 6. 30 and 1 is no, that's not going to work. 6 and 1. Oh, this might work. 6 times x. That's 6x and 5x. No, that's not going to work. So, sorry. Humor me for a second here. It could also be 2 and 3. That would be 2x and 15x is not going to work. 3 and 2. 3x and okay. That's not going to work. It doesn't factor, folks. Sorry. It's not that I didn't trust you. I just wanted to make sure for myself. It doesn't factor, which means we're stuck with quadratic formula. Yay, we get another opportunity to practice quadratic formula. Nice. It's my favorite thing in Precalculus. I do kind of like it. It's easy. If you haven't gotten to the point where it's easy, you just haven't been doing it enough. So. Has anybody adopted my strategy of writing out the format first and then coming back and filling in the numbers later? That cuts back on a lot of time for me. It makes it way faster. I always start like that. I come back and put my B's in here, here. Put my A's in here and here, and C in here. There's 36 plus 20 times 6 is 120. 156. I bet that simplifies. $156. Is that divisible by 4? It is. Uh-huh. $156 is 4 times 39. Ooh, easy there, right? Square root of 4 is 2. Oh, I'm running out of space, but I'm almost there. That would be 1 over 5. So 1 over 5 root 39. Or I could write the root 39 on the top. So good news and bad news. What do you want first? Bad news? Not really bad news, but it might sound like bad news to you. The quadratic formula is not going away. We're going to be using it all year. You'll be using it in calc a bunch. It is not going away. Super important. Comes up again and again and again. You want to know the good news? Once you've done it enough, it's not that big a deal. I mean, you gotta go through a bunch of steps and simplify and everything, but once you've done it enough, you should be able to rip out an answer like that in 20, 30 seconds and be moving on to your next problem. So, but if you're not quite there yet, that's okay. Every time you do it, you're gonna get a little bit more confident, a little bit faster. All right. So next time you have to do the quadratic formula, don't go, oh man, quadratic formula again. Say, yay! After I do this, it's gonna be even faster for the next one. Right? All right, let's verify this thing numerically. Now, I do not want to take that and plug it back into my original equation. So we'll definitely be letting the calculator do this for us numerically. I'm going to go back to my original equation. And I don't have a whole lot of space here, but let's rewrite this with a 0 on one side. So just scooch that 5 over to the left-hand side. That would be 3 over x plus 1 over x plus 2 minus 5 equal to 0. Let's go to our calculator, stick this in for y1, and then do our second calc value and type in our nasty quadratic formula answer and make sure that we come up with 0 for our y values. So all right, so graph it. Ooh, that's a funky looking graph. Hey, I see 2 x-intercepts. That's good because we got 2 answers, right? So I'm going to go second calc value and type in this. Negative 3 over 5. I'll do the plus version first. Plus 1 over 5 times the square root of 39. And hit enter and keep my fingers crossed and hope that I get a y value of 0. Does it work? Oh, please work. Yes. Beautiful. And then we'll do the same thing with the minus here as well. Negative 3 over 5 minus 1 over 5 times the square root of 39. Fingers crossed for another 0. Verify. All right, any questions? Got one more example to do that illustrates one final thing that we got to do with these. The whole idea is clear the fractions and then solve. Like if we were going to do a step-by-step thing, step 1 would be clear the fractions. We did that by multiplying through by our LCD here. That's this stuff right here. And then solve. And that was just, basically algebra 1, algebra 2 stuff. There's a final step that you have to do, which is check and make sure that none of your solutions are what are called extraneous solutions. Have you guys heard that word before? Extraneous solutions? Extraneous solutions are ones that come out when you do the algebra correctly, but don't actually work in the original equation. There are 2 values that I would need to look out for in this original equation that I cannot plug in for x? What are the two values that I cannot plug in for x in this original equation? For fear of causing the universe to collapse in on itself and everything we know and love to cease to exist. Give me one of them. -2 would be bad because then I would end up having 1 divided by 0. What's the other number that would be bad? 0 would be bad. And you have a third, or were you going to say 0? You were going to say 0 also. 0 would be bad and -2 would be bad. Right now, I don't need to worry about that because we didn't get either of those answers. But our last step, we always got to check and see if we have an extraneous solution and toss it out if we do. Okay, so this next one, spoiler alert, it's going to have an extraneous solution. Probably, hopefully. If I built it correctly. All right, number 2. Well, for example, number 3, I guess. Example, our last one, this time, well, let's write it out and then we'll separate it. I think it's a good idea to write it as it is and then rewrite it, separate it out. We're going to want lots of space in between, though. So let's talk about fraction busting this thing. We're going to end up multiplying by some LCD. What factors am I going to need in my LCD? This looks like an x plus 3. And that's different. So we're going to need that guy also, x minus 2. Am I really going to have to multiply it by that thing too? Does this factor? All right. And 9 times out of 10, if you see a quadratic in the denominator, it will factor. And it will factor into something that matches the other two. So use that kind of as a guide and check. If I'm going to just check, I think it's probably going to be x plus 3 and x minus 2. And is that going to work? That's going to give me the -6. It's going to give me the x squared. It'll give me a 3x and a -2x, which does add up to x. Yes, it does. So since I've already got both of those factors in my LCD, I don't need to add anything else in for this third fraction. This LCD covers all of the factors of all of my denominators. We good with that? So I'm going to go ahead and rewrite my function. It's not, why do I have f of x out there? I'm sorry, can you get rid of that? That's not an f of x. I don't know why I did that. I'm going to rewrite my equation. Excuse me, that's really confusing. I apologize. I'm stuck in function land. This chapter is kind of weird because we do switch from equations into, or from functions into equations. And then, has anybody looked ahead to see what 2.8 is? It's inequalities. So we go from functions to equations, and then we'll do inequalities, which is where we'll learn to build sign charts. Oh, you're gonna love it. But that's not today. So let's rewrite this equation, not function, but I'm gonna leave some space in between my different terms. And when I write out my last term, I'm going to go ahead and write it in its factored form. So now it's time to do the fraction busting. This is my favorite part. So we're going to multiply each of these terms by our LCD. And our fraction should melt away. I don't know why I'm writing this out of order. It's confusing. Feel free to use sound effects when you do this. It's a little more neat, amusing. Pew. Kapow! Kapow! Look at that last one. That was very fulfilling. Look at all that stuff canceling out. Oh, it feels good. Cool. No more denominators. What's left over here? We got 2x times x minus 2. I normally probably wouldn't write this step out. I would actually do the distribution as I'm writing it. Some of you may be doing that right now. That's fine. This is our notes. So I tend to write more steps when I'm doing notes than I would if I were doing it on a homework assignment or a test. So some of you are going to find that you're comfortable just doing the distribution right in that step is your next thing. But again, I'm erring on the side of more work for our notes. Oh my gosh, I hope this works. It's a quadratic again. Yay! We might get an opportunity to practice the quadratic formula again. Or maybe it'll factor. I don't know. I'm going to get a 0 on one side and combine like terms at the same time. High stakes move here. That's going to be a 1x. And then if I do minus 25 on both sides, I think that's a minus 10. Does that factor? Woo! All right. That's going to make our lives much easier, provided we're confident with factoring. Let me just throw it out there again, folks. If you are having any trouble with factoring trinomials, that's something that we need to fix. We're going to be doing it all year long. Okay, and they're gonna turn into more complicated things. There won't be 2x squared plus 1x minus 10. Next semester, it's going to be 2 sine squared x plus 1 times sine x minus 10 equals 0. And you're gonna have to be able to factor that. And it's not hard. It's the same as this, but if you're not comfortable doing it with x's, you're certainly not going to be comfortable doing it with sines and cosines and tangents. So please let me know. We'll find a time that we can meet before after school. I can get you caught up real quick. You're gonna have to do a little bit of practice, but I can get you the basics down and you can practice a little bit and get yourself where you need to be. So I'm gonna say that's 2x and x, and this has gotta be 5 and 2, right? 2 can't be there because that would be a GCF, so that's gonna be a 5. It's 5 and 4. We want it to end up positive, so we want my 5 to be positive and my 4 to be negative. Yay! And then if I were showing all my steps, I would use my 0 product property and split those factors up and set them both equal to 0. I probably wouldn't write this stuff out if I were doing it on homework. Because probably most of you right now can look and go straight from 2x plus 5 to x equals negative 5 over 2. Right? Are you most of you feeling pretty confident of going straight from x minus 2 to x equals 2? If you are, you're welcome to skip this step right here. Hooray! We got 2 answers, negative 5 over 2 and 2. But what? We're going to plug it back in. Let's just double check and make sure none of those are extraneous solutions. What are the 2 values that we're going to need to avoid based on our original equation? Negative 3 would be bad and positive 2 would be bad. And since those also are the same factors over here, those are the only 2 we need to worry about. Do we need to throw any of our solutions out? X equals 2. That is not going to fly in our original equation. So we'll toss that out. Let's make a note that this is what's called an extraneous solution. I'm going to show you guys how to verify this one graphically. And I need you to recognize something here. When I show you this, I am showing you how to use your calculator to solve any equation ever. Any equation ever. Okay, like ever, like really, seriously, any equation ever. All right, so check it out. Here's what I'm gonna do. I'm gonna go back to my original equation. Rather than get a 0 on one side, I'm gonna plug these two things in for y1 and y2. So this is a little bit more complicated than what we did a second ago, but I want to make sure that you understand that this can work. This is an option. There are times, like in an engineering context, where you don't want to sit down and take time to solve something like this algebraically. You just want a decimal approximation for a solution. And if that were the case, this is how I'd be solving it. So I take my two sides of my equation, plug one side in for x1, y1, side in for y2. So let me stop chatting. Do that. Stop gabbing. My other one is square. And when you graph this, where do you suppose we're going to be looking on our graph? We're going to look for where these two graphs intersect. And the x value of where they intersect should give us our solution. So the newer calculators that give you a color version are a little bit easier to kind of see the difference between the two. So that's not super easy to see intersections on this one. Huh. I may have led you astray here. Is there a... Where are they crossing? Yeah, we do. So it's well, we gotta find it visually on the graph first. So it looks kind of like they're intersecting down here. So like I said, this isn't always the best way to go about this. I'll tell you what. Let's backtrack. Well, let me show you how to do this. Okay. So we need to find it. I'm gonna go to my window and I'm gonna zoom in. Actually, let me show you the zoom box thing. It looks kind of like they're intersecting. We know that the intersection is a negative 2.5, right? So I'm going to guess that it's somewhere in here. Go to zoom and do zoom box, which is your first option. And what you're going to do is you're going to click twice with your cursor and you're going to click in opposite corners of your box. So click once where you want the top left corner of your box to be, and then drag your box down and over to include that little spot. You see what I did just there? So I'm telling my calculator to zoom in on that little spot right there. So this is the zoom button and zoom box. Move your cursor and click once, and then move your cursor around and click again, and that'll give you a box. And when you hit enter for that second time, then it's going to show you that piece but zoomed in. And I'm hoping we can actually see the intersection here. Oh, no, bummer. Looks like it's happening a little bit down below here. We need to go down a little bit further. So how can we make our window go down a little bit further? Window button. Go to your window button. Where's it going down to right now? It's going down to -9. Let's make it go down to like -20. Please show me the intersection this time. There it is. Okay. I can barely see it. You know what? We're not going to do this. This is a bad example to do this for. This is a really bad example to do this for. What's our other option to verify it? We could get a 0 on one side and plug it all into 1. Let's do that instead, since we're already halfway there. Go back to y equals. Clear out that y2. And would you agree that I could just take this equals and turn it into a minus and put the equals 0 over there, right? So finish this equation up. Go minus 25 divided by x squared plus x. We'll find another opportunity to show you that function on the calculator. This problem is not a good example for it. So I'm falling back on what we did in the first two examples. I got a 0 on one side. That should be a minus, not a negative. Then I'm going to go back to zoom 6 when I graph it. So do zoom 6, and this time just look for your intercept. There should only be one because we only had one solution, and there is only one. Hey, nice. And it looks like it is at negative 2.5, and we can double check the second calc value. And we got our intercept of 0. Okay, my apologies. We kind of took a dead end road there for a couple minutes. That happens sometimes. All right, the big things that I need you to know are from today. Do you feel comfortable finding an LCD and using it to bust your fractions? Do you feel comfortable that you're going to remember? This is the hard part. How are you going to remember to go back at the end and check for extraneous solutions? That's the part I always forget to do. I was the person, I would have got the whole problem right. I would have forgotten to do that. And I would have gotten like a 9 out of 10 for the problem. Anybody else in that boat? So you got to come up with some strategy. Some of my students will, straight from the beginning, before they even start the problem, as soon as they get their LCD, they'll say x not equal to negative 3 and x not equal to 2. And then they'll draw a line from, usually I put a spot on the test for you to make your answer. They'll draw a line from the answer up to that to remind themselves to go back and check and make sure. So that's that strategy where you do the thing you expect to forget. You do it at the beginning rather than trusting yourself to do it at the end. So. The other thing I want you to be comfortable doing is, if we get an equation, you feel comfortable getting a 0 on one side and using your calculator to check your solutions. Those are the two main things that I want you guys to be good with today. So our assignment is on campus. Oh boy. Anybody write it down yet? I didn't. Well, I can tell you it starts on page 253. I'm going to double check this in a second, but I'm pretty sure it's 1 to 6 and 13 to 18. Let me pause here and go back to Canvas and double check that though. Tuesday, verified, yes, 1 to 6, 13 to 18.